So in the future, if I want to use the Chromapolis platform and I have an ID, I have a massive multiplayer game, or I have a prediction market, or I have a land registry, or I have a hotel booking system, or I have a logistics coordination system, what will be my developer experience? What will I need to do? How do I code anything? Or where do I start? Where will I start?
Well, we already have actually documentation on our website. It's called Dev Preview. It comes with something like integrated development environment. Of course, it's kind of rudimentary, but...
So there's an IDE, so that I can download.
Yes, you can, basically it's packaged in a Docker. So you can, in this Docker, it comes with web-based editor, which supports like development of multiple modules. And we have a backend which a single node, which basically it's not Chromapolis, it's just one isolated node, but for the DApp it will know basically won't really make much difference. So because
there is an IDE, so there is a alpha IDE today, which you can run,
yes.
You can download. You need to have Docker Compose. You do Docker Compose up, and it starts. But in the future, Chromapolis is going to run, like you should be able to dev on any editor. It's called language server or something?
Yes, yes. We plan to improve this language tool, so we are making make an Eclipse-based plugin, so you can develop using Eclipse. And also the same infrastructure allows language server protocol, so potentially any editor can basically use this editing tools and kind of verify the code. You can get basically, if something doesn't compile, it will tell you right away. And also there is integrated testing environment, so you can test your application and write tests actually.
In the IDE?
In the IDE. And
yes.
yeah, and around your application, basically you can start from a fresh start basically, and execute this basically for the servers parts, and connect the front-end parts to basically carry out development and testing of these things.
And there's a language called Rell, which you're supposed to code in. Now, what is Rell?
Well, it's the language we developed since we first started with SQL, so actually post-chain supports SQL. You can make an blockchain, new blockchain schema using SQL and stored procedures, for example. But we found that it's a kind of frustrating experience because SQL is very verbose. Also,
so what you're talking about, you could actually develop on the JVM, you could use Kotlin or Java, and then SQL, and that together would then make up the blockchain logic, right?
Yes, yes, that's what we started with, and this option is still available. It might be relevant to enterprise development, which actually like SQL. But yeah, we found that it's a frustrating experience, and it does also have certain limitations, so we cannot support blockchain features like state commitments using SQL. It's going to be very complicated. It requires certain kind of schema and instrumentation to be done on every update. So we basically decided to make our own language, which combines basically normal programming, like imperative programming, with relational queries, updates, data retrieval. So we may, and yeah, we thought like maybe we can use SQL, but turned out that it's not a good idea because it's very verbose, and most programmers do not like actually writing code in SQL. They use all kinds of tools like ORM, for example, to avoid that. So we thought like if they want to avoid that anyway, maybe we should make a language which actually makes it convenient. So it's very kind of conscious notation for queries, It's very logical, so you don't have to think like, how do I put this together? It follows quite naturally, so you can, and it has much better type checking because we have both data schema and the code in the same file. Also, we do type checking of entity references, unlike SQL where it's just an integer. It can be misplaced. We actually type check these entity references. So it's much safer program, easier programming, safer than SQL. Like if you have a problem where the code you wrote doesn't make sense, it will tell you right away that it doesn't compile.
So you basically integrated relational algebra into the application development language for security reasons or for verifiability reasons.
Yes, it's not exactly relational algebra. Of course, it's inspired by relational algebra. It was inspired by SQL as well. So yes, it's. I think it's much easier that way. That you don't have like two parts of code, query and normal code. You just have code with native query construct. So it's much easier. You don't need to think, oh, I need to have a query here. You can just write whatever you want, and it's compiler's business to make sure how to execute it.
And corporate customers and other customers, if they really want to, they can use SQL and anything on the JVM directly if they want to.
Yeah, for post-chain, they won't be able to do it on Chromapolis because on Chromapolis we want only verified queries, verified code, which is much easier to do using our own language, basically. The language excludes the constructs which are not secure. For corporate users, I would also recommend Rell because it's easier to code, much easier to code than SQL. But if they have like special requirements, maybe they want to use existing schema, or they want to use, let's say, some Java libraries which already exist in, they can do it. So basically, we have a framework. It's very flexible. It can allow different languages, different approaches, different libraries. You can actually change consensus or change signing schema, crypto system, or change data structure. For example, you can, maybe by requirement, by law, you have to use certain format like XML, signed XML. It's not used anywhere in the blockchain space, but if that's what you want, you can do it with postchain.
So what does Rell look like? Does it look like JavaScript or Kotlin?
It looks, yeah, we use Kotlin for postchain development and Rell development itself. We really like this language, so it looks a lot like Kotlin. Of course, there are some constructs which we kind of disagree with Kotlin, and we made it our way, taking inspiration from other languages like SQL. And the relational constructs, we invented them. We invented them ourselves, so they do not look like anything familiar. Just like very conscious notation for the queries. But the rest of the code should be familiar for people coming from Kotlin or TypeScript. You can basically change maybe some keywords, and you will be in the familiar place.
So similar to Kotlin and TypeScript as possible, basically, and then when it makes sense from an efficiency or expressiveness perspective, there are other constructs in the language that makes it more efficient.
Yep.
So is it a typed language or untyped, or?
Yeah, it's statically typed language, so every expression has a type. In that sense, it's very similar to Kotlin. In TypeScript, you have TypeScript is kind of different because you can have any, which is kind of not good. It's basically designed to go from JavaScript. Also, you can have type everything, but in Rell, everything is typed, so we don't have untyped constructs.
Does this typing also extend to the queries and mutation of the relational database?
Yes. It's basically type checks everything which goes from query to query and within the query itself as well.
And that makes it different from SQL usually, how it works in most IDEs, that it's hard to...
Yes, SQL, it's a typed language, strictly speaking. but it allows many implicit conversions, also identifiers, usually just integer, so there is no identifier for some kind of object you have in the database. Actually, Rell is, it takes metaphor from object-oriented as well, so that's another difference, that we have not just tables, we have classes with objects which are persistent, which are it's the same thing as tables, but you can think about it in a different way, which is helpful, I think. So yeah, it's different from SQL in that way.
So what capacity does Chromapolis have in how much data can it store? How many transactions of second can it process?
Well, we have no idea because it's not running yet, but we have done some synthetic tests. So what we are aiming for is that it might be able to process like 500 transactions per second per blockchain. Of course, if you have bigger requirements, you can run many blockchains, and you can do thousands. Like within one blockchain, you can do 100,000 updates per second or 100,000 queries. So these transactions can be actually bigger. So if it complex transactions which requires many updates, many interactions, it's actually feasible because we kind of use hardware more efficiently. Database software is optimized to handle all these updates and reads in efficient manner to use hardware basically efficiently. So this way we probably are better than most other blockchains. I don't know. There are of course now many kind of many blockchains advertise like millions transactions per second, but it's not clear whether it can be carried out outside of the laboratory environment, basically, where you have everything in memory. We are aiming more at sustainable operations over a long time. So yeah, also in terms of data sets, you are not databases. You know that databases can handle terabytes of data. So potentially, since Chromapolis uses databases, there are also no limitation in this way. Of course, it's if you have single blockchain using these terabytes of data, it's going to be complex when you need to move it between nodes. They need to sync terabytes, but also since nodes are professionally hosted, they probably should have the resources needed to move terabytes. It's not going to happen over 1 second, but let's say this migration can take a day, but we rely on these nodes being sufficiently stable. They shouldn't like disappear each hour, for example. So it should be feasible to have terabyte-sized data sets in Chromapolis.
What does excite you most about Chromapolis? What do you feel that this is really interesting?
Well, I'm excited that we can run. Basically, we are making it to be able to have new kinds of applications which haven't been possible on other blockchains. So we are doing it to basically get away from limitations. And I'm really excited to see what will come out of it, like what new kinds of applications can be developed, and how it can basically reach a much wider audience of users using this decentralized kind of environment. So currently, most users use only centralized services, so it will be really nice to see people actually not just experimenting with something, but using something decentralized in their daily lives.